Hey everybody, welcome to Unit 7, which is going to be going through Chapter 5. Remember, we do kind of mix around the chapters through the book that we go through. This chapter is all about solving systems of equations. It's really just a way to say finding where two lines intersect. We're only going to be doing linear equations. That's all that we're working on this year. So we're just going to find where the two lines, we're going to graph two lines. We're going to find where those two lines intersect. If you think about two lines, I'll draw it over here. If it works, let's see. There we go. Okay, if you think about two lines, one line, two line, there's only one possible place they could intersect. There's zero ways that a line can intersect more than once, except for one special situation that we'll talk about later. Okay, so we're going to find the one point where those two lines intersect. All right, so the first thing that you're going to do for this is you're going to make sure your lines are in slope-intercept form. Remember slope-intercept form, the thing we've been studying for the last month, it feels like, or longer than that, is y equals mx plus b. Okay, notice I put my m in red, my b in blue. That's because those are the important parts. You should know what those stand for. If you don't, definitely go back and review some other stuff. But if not, rewrite it and solve for y. Okay, we're really only dealing with slope-intercept form right now because it's the easiest way to graph a line. There's other forms of line like standard form, point slope form. You'll learn all those later. Right now, we're just going to deal with slope-intercept form because it's easy and it works. Okay, so what you're going to do is for each equation, you're going to identify the slope, which is your m value, and your y-intercept. Okay, which is your b value. Your slope and your y-intercept. The next thing you're going to do is graph each equation. You guys have all done this before. You've graphed lines from slope-intercept form. The first thing you do is plot the y-intercept. Which remember you do by just going on the y-axis to wherever that number is. From the y-intercept, you apply the slope to find the remaining points. And the last thing you do is connect all the points with a line. So you just draw a line through them. If you have a straight edge of some kind, that's great. Those little protractors are great for it. The edge of a notebook works really well. If not, just do your best. Then step 4, you're going to locate the point that the two equations intersect. The two equations intersect. Okay, that's your solution. Okay, solution, not solation. Let's see if I can do that again. That you actually erased it well. Oh, and then I kept erasing. Solution. There we go. Okay, that's your solution. And your solution should be in the form of an ordered pair, which is just x, y. Okay. And after you get your solution, you box it. That's just to help you understand where it is. It's a visual representation of the actual solution for things. And so I'll give you some examples of these. So we'll do a green line. If we have a one solution system of equations, we have one line. And let's do like an orange line. That'll be nice. And this line, your solution would be right there. It's where they intersect. It's the exact point they intersect, which on this one is 0, -1. All right, no solution. would be, we have the green line like that, and the orange line like that. Those are parallel lines. Those lines are never going to intersect. There's no possible solution that fits both of them. And then infinite solutions, think through what that would be real quick. What kind of lines would have infinite solutions, would intersect infinite times? That's right. If it's the same, I don't know if you got it right or not. If it's the same line, then it's infinite solutions. Okay, if you're just working with the same line, if there are two lines that are the same, you have infinite solutions. There's three types: one solution, no solution, infinite solutions. Primarily, all of them will be one solution. Not all of them, but most of them are going to be one solution. These are two special cases that we do need to touch on, though: no solution and infinite solution. The examples we're going to go through on these, we're just going to graph some lines and see where they intersect. That's all we're going to do. So I'll make this one the green line, and this one the orange line. It's helpful to have two colors here. So let's graph this green line first. It has a y-intercept of -5. We're subtracting 5, so it's -5. -1, 2, 3, 4, 5. So we have one green point down there. And then we go up 4, 1, 2, 3, 4, and over 1. And we just connect that. And it's not really straight, but that's okay. Okay, that's actually pretty awful. I'm going to redo that. So we're going to go up 1, 2, 3, 4 again. That's 3. So 1, 2, right there. Okay. So there's our green line. Our orange line is going to be -2x plus 1. So we add 1. Excuse me, we go up 1 because that's our y-intercept is +1. Then we go down 2 over 1, down 2 over 1. Or we can go up 2, left 1. Where they intersect is our solution. So our solution for this one will be 1, -1. It's just the point where they intersect, which is right there, 1, -1. So all you do for these, you just graph them and find the solution. Example 2. Jump down here. We have the line y equals 2. Make that my green line. Make this one my orange line. Remember, the line y equals 2 has a slope of 0. It's really 0x plus 2. Be our formula for that. And it has a y-intercept of +2. What that means is no matter what x equals, y always equals 0. So if you're thinking ahead, you can do the solution as something 2. Because the y value for this always has to be 2. The other line, the orange line, can't intersect the green one at any value, y value other than 2. Okay, so let's do our second line, our orange line. 1/2 x plus 1. Our b value is 1, and our slope is 1/2. So we go up 1, over 2, or down 1, left 2. You can see where they intersect. They're intersecting right here at this point, which is 1, 2 over and 1, 2 up. So it's the point 2, 2. Okay, 2, 2. And we should box that as well. There's our solution. Example 3. 3x minus 1 and 3x minus 4. Think about what you notice about those two equations real quick. Okay, the slope for these is the same. Real quick, pause the video, think about what that's going to do to the system of equations right there, the solution for the system. Where are they going to intersect? All right, let's figure it out. We got 3x minus 1. So we go down 1 right there. Then we'll go up 3 over 1 or down 3 left 1. Or it's always good to make multiple points. You can put another one up here if we want. Okay. I'm doing my best to draw some straight lines. I already have such good handwriting, and this computer makes it way easier to draw things on. 3x minus 4 is our next one for the orange. So we'll go down 1, 2, 3, 4. Up 3 over 1. Up 3 over 1. And up 3 over 1. Okay. It's a pretty straight line. I'm pretty proud of that one. So these two lines have the same slope, which means they're parallel lines. Actually, I'm not proud of it at all because I realized like an entire unit off. But in theory, if I drew them right, they should be parallel lines. Are they ever going to intersect if they're parallel? No. So what we write for this is no solution. There's not any point in the history of points, in all of the points on the entire coordinate plane, where these two lines will intersect. So there's no solution to it. All right, example 4. I want you guys to pause the video, try this one yourself. When you're ready to unpause it and check it, go for it. Okay, now that you've tried it yourself, let's make this in the green line, this in the orange line. It doesn't matter what color you use, by the way. Just happen to choose green and orange. So this one, negative x plus 4. We have a y-intercept of 4. 1, 2, 3, 4. I'm going kind of quick on the graphing because we've done so much on it that I don't want to have to go into that too much. You guys should have a pretty good handle on it. We have a slope of negative 1. Remember, we have negative 1x. So we go down 1, right 1, or up 1, left 1. And you can just keep going down. Oh gosh, that was a terrible line. Oh, it's a little better. We'll use that one. Okay, good enough. All right, the next one, negative 1/4 x minus 1. So we have a y-intercept at negative 1 and a slope of 1/4, which means we go up 1 over 4. Remember, it's always rise over run. Up 1, over 1, 2, 3, 4. Oh, they intersect right there. Down 1 over 4. Okay, and I totally missed that line too, but you get the point. We should have a point right there. That should be our solution, which is on the x-axis. So we're going to have a x value of 1, 2, 3, 4. And a y value of 0. Okay, we go 4, 0. That's our point. Okay, you can check these, by the way, by plugging them back in. So if I plug in 0 for y, and 4 for x, so negative x, negative 4 plus 4, negative 4 plus 4 is 0. So it works. Okay. So this one, 0 for y equals 1/4 times 4 minus 1. 1/4 times 4 is 1. 1 minus 1 is 0. So it also works. Okay, you can check and see if you're correct like that. Example 5. Okay, we'll do this one again together. Then I'll let you guys do example 6. Or actually, let's do example 5 together. Yeah, then I'll let you guys do example 6. That's exactly what I just said. But we'll do it that way. All right, you notice that this one over here is not in slope-intercept form. We do not have a y equals. We have to solve for y. To solve for y, we just have to get it by itself. Okay, we're adding x to it right now. The opposite of adding x, subtracting x. So we can split our equation like that. Y equals 5 minus x. Still not in slope-intercept form. We have two terms though, and we can just switch those around and get y equals negative x plus, it's a positive 5. Okay. We can make this one our green equation and this one our orange equation and graph them. Plus 5 means we have a y-intercept of positive 5. Okay. Negative slope means we go down 1 over 1. See if I can get this line any better. Nope. Third time's the charm. Let's see. That's terrible too, but we'll take it. I'm not going to do more than 3 times. Orange line, 3x minus 3. We have a y-intercept of negative 3. We'll go up 1 over 1. Up 1, sorry, excuse me. Up 3 over 1. Up 3 over 1. And that's as many points as we can put on there. You might notice these are all intersecting at nice even points. You might ask yourself, do they sometimes intersect at decimals? And the answer is yes, but we're not going to do that with graphing ones, really. Okay? There's a bunch of different ways to solve these problems. There's at least 4 different ways to solve them. And there's probably, I mean, there are a lot more than that. There's 3 to 4 kind of basic ways you'll usually learn. We're not going to go through all of them. We'll go through about 2 of them this year. Graphing is probably the easiest way to solve it. But it doesn't work for all of them. It only works if they intersect at a nice even point. Okay, so all the ones we'll be giving you for graphing do intersect at a nice even point. They're great. Yeah, this is the solution to that one. It is 2, 3. Okay, so 2, 3 is our solution. The last one, pause the video, try it for yourself. Remember, you're solving for y. You're getting y by itself. And then you're graphing it. We're ready to go on, unpause the video, and we'll go over it together. All right, to solve for y, all you have to do is get y by itself. The first thing that's happening is negative 4x being added to it. If we add 4x to negative 4x, we get 0. We cancel it out. So I'm going to do that on the left and right side. 2y equals 2 plus 4x. Now, I have 2y. I need to figure out what 1y is. Opposite of multiplying by 2, just dividing. So divide the left side and the entire right side by 2. And we're left with y equals 1 plus, okay, 2 divided by 2 is 1. 4 divided by 2 is 2. So 1 plus 2x. If I switch those around, whoa. Okay, my thing just went way off to the right. 1 second. There we go. Okay, if I switch those around, I get y equals 2x plus 1. Well, if that is our green equation, this is our orange equation. What do these 2 equations have in common? Everything. They're the same equation. Y equals 2x plus 1, y equals 2x plus 1. They were in different forms, but they're the same equation. Let's graph them just to make sure and see what happens. Y-intercept is 1. Slope is 2. So we go up 2 over 1, up 2 over 1, or down 2 left 1, down 2 left 1. Okay. Then let's do this one. Y-intercept is 1. Up 2 over 1, up 2 over 1, down 2 left 1. If I drew it right, they'd be exactly on top of each other. They have infinitely many solutions. So to write that out, you just write exactly what I said. Infinitely many solutions. Okay, infinitely many solutions. All right, there you go. There's your graphing, excuse me, solving systems of linear equations by graphing. This is 5.1, Unit 7. Let me or Mr. Moore know if you guys have any questions. And yeah, have a good day.